Wait a minute, I will set it there. I have not put charger. Wait a minute. Hope it will not spoil the settings. Voice clear? Voice is clear? Not clear. Okay, I will start. Make a note. See, one note you have to make. So far, for cantilever, either fixed at left or right hand, for any type of loading like couple, point load or UDL or UVL or one more UVL, I removed it. It will bend like this. You know how to find deflection at B, not actually Y at free end, and draw a tangent, you know theta at free end. Or if the cantilever is like this, it will be here, Y at free end, theta at free end. See, here clockwise, here anti-clockwise. Y is down. So this will give you theta max and Y max. Clear? This will give you maximum slope and maximum deflection. Correct? It will give you maximum slope and maximum deflection. Tell yes or no. One by one we'll go in order now. I will go one by one in order. See, I told I am going to cover this particular part in detail. So those who do not see, no point. There is no, what I call is no point in thinking that it is not required. You can learn it. Okay. Now what we will do is same case. Either cantilever beam subjected to couple, or cantilever beam subject to point load, or cantilever beam subjected to UDL, sufficient. These are all not required, because I should keep in mind the objective questions also. For these cases, see, you know either there or here, anything, see, anything. You know how to find free end. Suppose somewhere else you require, anywhere else you require, what to do? That formula you can't apply. Now, for that, we have one minute now. If you need somewhere else, what to do? See, therefore, I write here, how to find slope theta and deflection Y. You should write Y. Where? Not maximum. anywhere in the beam, anywhere in a cantilever beam. Cantilever beam. So I will do one thing. Say a random point. A random point. Say I will call R. R means random. Any random point. See R here. R. There are two options right here. There are two options. All you are right. Two options. Option one. Use moment area method. This also I explained for you. Moment area method. No confusion. Option 2 is, one is moment area method. Option 2 is some special method. That is option 2, I can tell you, it is a trick. Some trick. You can write trick, no problem. Trick means, what is the trick, I will tell you. First I will take example. I will tell what is the trick. Trick or what? Some special trick or some special concept. Both are equally effective. Okay, but see one by one. You should make all this note. Okay, I'll start now. First I will take, see. I will tell the trick after I start a question. I will tell the trick. See, 1 minute now. I will do one thing now. See, question I will write here. Question I will write here always. See, a cantilever beam of length, any length. Okay, I will do one thing now. I will take bookwork now. Say length L. Okay, let it be L only. Numerical, you take homework. Is subjected to a couple M at the free end. See, A, B. Cantilever can be this way also. Don't by heart left side, right side. You are right here. You already know how to find slope at B and deflection at B. Already over last time. We will not do once again. Why? Each class we will do new things. Now, required to find slope and deflection Y anywhere. Usually they ask you center, but I avoid center. Why? Center means easy for you. See, L by 2. Say Y at any point. See, L by 3 from free end. That is at, see, L by 3 from free end means that is at what? 2L by 3 from fixed end. Don't by heart fixed end. Say a new random point. It is a random point, new point. I will take the point as red color R. Say R. So therefore, the question becomes cantilever beam. See, span L, a couple M here, A, B. I will put L here. See, this is L. A random point here, R. It is given in the question, where from here it is L by 3, from here it will be 2L by 3. I will give a numerical homework for you, work out that one, over. See, I will first go for option 1 here. I will go for option 1. Option 1 is by moment area method. Okay. I already told very clearly and systematically that if slope and deflection are required at any random point R, then what to do? Sorry, I will not tell what to do. What to do. You should write here. For your reference, I will tell you slope at R equal to what I told you. Where in a cantilever beam, wherever you want slope, whether free end or any point, that slope equal to area of BM by EI diagram between which points? Between that point where you want R and which end, tell me. I will not repeat, there is a limit. Those who are newcomers, once again start from that shortcut for candidates, class number 3. This is a part 3. Study everything, not suddenly come today and tell what is going on here. Everything study. Tell me, I told by moment area method, I told theta r minus 0 I want. Area of the BM by I diagram between that point r and which point? Other point is always standard. Which one? I told you very clearly earlier. Not once. Systematically told earlier. And fixed end. R and fixed end. Remember. R and fixed end. Okay. That's all. And I told you deflection at the point R is moment of the area of BM by EI diagram between that point R and fixed end, but very important, tell me about which point. This also very clearly I told. That moment about which point? Tell me fast. In the first explanation, by mistake, I wrote a statement. I was insisting on fixed end, then I corrected it. It is now a print mistake. Moment about R. Moment about that point where you want slope and deflection. R. Okay. Today's class, I want to complete it now. Full I want to complete. Okay, start. Now, this is permanent now. Start our question. Our question is cantilever beam. See. This is the load W. Span is L. I will put span L here. First draw BM. This is, why where's that? This is L. Okay, L. First you draw, or I will put L. Okay, L here. Okay. L. I will put L here. Little space I require. L. First you draw BM diagram. This also I told 1,000 times for you. Fixed end, reaction moments are there. Look that side. Bending moment here, 0. Bending moment here, W into L. Actually, I am wasting time. I already explained very thoroughly. It is hogging, negative, but moment area method, sign not required. Why? Because sign you get by elastic curve. Okay, then. Elastic curve will become how? Elastic curve will become this way. Now, this is that point R. This is the point R. If that is the point R, in the BM by EI diagram, that point R is here. Where is that point? See, for bending moment diagram, 0 to WL. R will not come for bending moment diagram. Now, you also need bending moment at R. How much? Tell me. Look this side. W into, see, this is L by 3. If that is L by 3, this is 2L by 3. I want to write once again here. See, this will not come for bending moment diagram first. Now, extra you want bending moment here. It is W into what? L by 3. So, this ordinate is red color WL by 3. And then, this is the deflection at R. And if you draw a tangent here, this is the slope at R. Clear? Tell me fast. Clear or not? This is the diagram. Okay. This is clear. This is clear or not? Fast. Is this clear? If it is clear, I can go to the next step. This is the elastic curve. This portion is clear. Okay. Now, if I want slope at R, I should consider this area. This area. From R up to fixed end. If I want deflection, I want moment of this area about R. A trapezium comes. What I will do is, directly trapezium formula is there. But so many people, they find difficulty for trapezium. So for them, oh, sorry. I am doing which one? I am doing couple. Where you are? Yo, I am doing couple problem. What is this? Nobody is telling anything. M. If that is M, what is this? See, that shows you are not serious. Steady. Bending moment here, M. Bending moment here also M. BMD is rectangle. Okay, this is a bending moment diagram. And at the point R also, it will be M only. Why? Same. Okay, now, this is the area. Clear now? That is for second question. You are not serious. You should have told me. We are doing couple. How would... See, no response. You should have told me. I usually point, couple is so easy. That's why I thought I am doing point load. Okay, now, start directly. I'll write somewhere here now. Space problem is there. Okay, then I'm removing that sketch later. Now, so I'll put here. Slope at R equal to, see, area of the BM by EI diagram from here to here, rectangle 2L by 3 into M by EI. Why? Rectangle area or equal to 2ML by 3EI clockwise. How? You see the diagram here. If the cantilever is that side fixed end, it will become anti-clockwise. See, if the cantilever is here, then it is this area. Okay, over. Now, deflection at R equal to moment of the area of this BM by EI diagram for this portion about R. See, about R equal to 2L by 3 into L by 3, 2L by 3 into L by, 2L by 3 into what L by 3? 2L by 3 into M is the area into moment about R, distance of its center of gravity from here. If it is 2L by 3, this is half of 2L by 3. Half of 2L by 3, rectangle. Divide by EI. Anybody can tell the answer? 2 by 3 into 1 by 2 into 2 by 3. What is the answer? 2 will cancel. Is it 2 by 9 ml square by EI down? Correct answer? 2 by 9 ml square by EI down. Correct or not? 2 by 3, 2 by 9 ml square by EI down. Correct? Let's check it. I do not want wrong mistakes. Okay. Now, those who want can do by Macaulay's method, take a section XX here, X from free end B, and then what to do? Get C1, C2 to get slope and deflection here, put X equal to L by 3 and check the answer. Can you do it? By Macaulay's method. Can you check this answer? See, this way if you learn basic concept, really full grip will come. Can you substitute X equal to L by 3? Why? Take origin at B, take section XX here. BM equal to M. Integrate 2 times. Yes, do it. Okay, now I will go to second option. Okay, that is this option 2. This is a special option. Remember, I am telling only once. In option 2, what you are doing is, I am dictating now. Only once I will dictate. I write here. In case of a cantilever beam, if any loading is there, not for this case, any loading is there, if it is A and B, don't by heart AB, fixed and free end. Suppose I want slope and deflection at any random point R, you consider new cantilever, a new cantilever from fixed end, up to only R, that is from fixed end only up to that point where you want slope and deflection. That is here. This is A, this is R. Or make a note. If cantilever, I will not tell again. If cantilever is like this, if it is A and B, if the point is here, R, then you consider only this cantilever up to R. Clear? You consider the cantilever from the fixed end only up to R. From R up to remaining free end, don't consider. Don't tell left and right end. See, here. Consider here and this is removed. Here, see. This is removed. Clear or not? Fast. I won't repeat again and again. I won't repeat again and again. From the fixed end up to where you want deflection. It is a very effective method. It is very effective. I will tell you, in case of change of EI, it is very effective. Okay. Now, for cantilever considered, whatever load is there, apply it. Whatever load is there, apply it. Here also. For cantilever considered, whatever load is there, apply it. Over. And which portion is removed? Which portion is removed? Anybody can tell me what to do? See, this load should be applied here. This load should be applied here. Okay, then loading on the remaining portion. That is, this is removed. This is removed. This is removed. So what you do? Which portion is removed? From there, you transfer equivalent force and couple. See, this full force, what is there? Transfer here. And whatever is the couple here, transfer here. Here, see, this full force, transfer here. And whatever is the couple, moment of that force about here, transfer here. Clear now? Clear or not? Which is, see, removing should be on free end side. Don't remove fixed end side. Then it will become nonsense. Why? Beam will fall down. Which portion is removed? That removed portion, whatever load is there, you transfer it to the point R. That is, when you transfer a load to a point, load with the couple will come. Past, clear or not? Load will come with the couple. You are not answering. Load will come with the couple. Yes. Then, now solve this question. Use this standard formula. Now your new span is this one. Okay. Now, therefore, write the statement. Second time I will not tell. Therefore, if I consider my, this is a general thought. If I consider my first question here, I want slope and deflection at R. Consider fixed end A up to R. Up to R. This is R. Let this side. Okay, R means in exam they can give A, B, C like that. I am calling RY random point R. Now, span of this cantilever will become 2L by 3. 2L by 3. And there is no load from here to here. Leave it. Here there is no load. If it is UDL, load will come. Then this couple here, see, there is a couple acting here. See, this couple you transfer here. No load is there. A couple M. Couple M. That's all because it's a couple. Over. Now the beam will bend like this. This is your deflection at R. This is your clockwise slope at R. Directly apply formula. Slope at R. For now this span L will become 2L by 3. Cantilever. Now your R becomes free end. See, now your R will become free end. So slope equal to ML square by 2EI. M is M only. L square is what? 2L by 3 whole square by 2EI. 2L by 3 whole square by 2EI equal to, tell the answer, 2 square by 3 square divided by 2. 2 square by, slope is ML by 2, ML by EI. Deflection I am writing. Slope is ML by EI. So M into L, this is your L. Answer equal to 2 ml by 3 EI, and deflection equal to ml square by 2 EI. Formula you write. If you want to write formula is what? ml by EI. General formula. This L is not that L. This is general formula. Here deflection equal to ml square by 2 EI is the general formula, equal to m into the L is 2L by 3 whole square by 2 EI. If you simplify, 2 ml square by 9 EI. Tell me, is the answer perfectly tallying or not tallying? Answer. Whether you do by moment area method or by what? Or by your shortcut method. Is the answer perfectly tallying? No. Answer, perfectly tallying or not? If it is not tallying, how I can stay in the classroom? No. If it is not tallying, how I can continue the class? No. See, no reply. Answer tallying or not tallying? If you tell yes, I will go to the next option. Illa, answer illa. See, just one word tallying required from you. Tallying. Okay. Now, take a homework. Imagine cantilever is like this. Couple I will apply here. 60 kilonewton meter. Span is 5 meter. I want slope and deflection somewhere here at 2 meter from here. This is A, this is B, this is, I will tell C. I want theta C and YC. Homework I will give you. You work out and get the answer. Cantilever is from that side. Be careful. Where's the calculator? I don't know. Where is the calculator? Here. Slope will come 120 by EI, radian anti-clockwise. Deflection will come that also will come 120 by EI meter down. Okay. You work out this question as homework. Okay, done. Okay, start. Second question. Clear, remove. Second question now. A cantilever beam has a length of any length. Length of 4 meter. A point load of 36 kilonewton is acting at the free end, ABC. It is required to find slope and deflection at a random point R. R is at free end, it is 2.4 meter. In the question given, center you do homework. 2.4 meter from the free end given. What is the slope and deflection at R? Question. Find what is theta R and YR. Start. Option by moment area method. Numerical problem it is. Load of 36 kilonewton. L problem, I will give homework for you. Span is 4 meter. Span is 4 meter. Our interest is a point, random point R at what distance? Oh, sorry, out of scale. I will do one thing now because that is smaller. I will make one from here 2.4 or I will make it 1.6 meter from there. Why? Space problem. That R is at 1.6 meter from there. Okay. Now, first draw, go to option 1. See, option 1. Draw bending moment diagram. Bending moment 0 here, bending moment here, 36 into 4 is 144. Joined by a straight line. Okay. This is the BMD. Okay. You write, this is the BMD. You can write this one. Already last time over. Now, we also require BM at this point. Which point? R. So, if you want BM at R, see here, 36 into 1.6. It is 36 into 1.6. If I ask you, tomorrow I will give the answer. 57.6. New bending moment, I will put red color. It is 57.6 calculated value. Okay, now this is the elastic curve. Okay, start. Now, what do you want? See, this I will remove now. Okay, this one I will put later. Now, I want theta r and y bar. I told you, theta r is this area, trapezium. Deflection at r is moment of this area about this point. Those who got capacity to consider trapezium, consider 144 plus 57.6 divided by 2 into 2. See, if that is 1.6, this will be 2.4 meter. 2.4 into 2.4. Moment about this point is 57.6 plus 144 divided by 2 into 2.4 into 57.6 plus twice of 144 divided by 57.6 plus 144 into 2.4 divided by 3. If you got capacity, okay, now general 99% they don't do that way. So for you I told you, those who got capacity I told, because why? This I explained for you. Or now what you do is, we want this area and moment about this point. You can do one thing. Take a rectangle and triangle. This is the point R. This is the point A. This rectangle is 57.6. And this is 57.6. And from this one, this base length is 2.4 meter. From 144, remove 57.6, you get the triangle height. Some people will tell, sir, this is better. 144 minus 57.6 equal to 86.4. Okay, over. See, in examination, objective question, how fast you can do now? Start. Now, theta r equal to this area plus this area. 2.4 into 57.6 plus half into 2.4 into 86.4 divided by EI. That much clockwise. Anybody can tell the answer? Something by EI. Answer fast. See, that's all. Exam they will ask only slope. They will not ask both slope and deflection. See what to do? Very fast. Divide and get the answer. Question of 20-30 seconds. What is the answer? Answer. Answer. 2.4 into 57.6, 241.92. So slope is 241.92. And deflection at R equal to moment of this area about R equal to 2.4 into 57.6 is the area into its CG is here 2.4 by 2 plus, now actually last class I decided general public when I take I want avoid trapezium because so many find difficulty. This is easier, so easier. Plus triangle half into 2.4 into how much? 86.4 is the area into distance of CG of that area from here, 2/3 of 2.4 by EI, that much meter down. Anybody can tell the answer? Fast. So you told theta r came 241.92 by EI and deflection. How much answer? Deflection. Fast. Deflection answer. Next we are going for the critical question. Next you are going for the critical question. 331.776. See now. 331.776 by EI. Over. This is the what? Deflection. So I will write the answer here. Answer 331.776 by EI meter. Okay. Now go to shortcut. I will go here now. Shortcut. If I go to this I can remove now. This all I can remove. Okay. Now if I go to shortcut, see now. Shortcut or not shortcut or tricky. or tricky or special. Okay, that is better. Not shortcut. Tricky or special. So, sorry. I told you, remove that not overhang. From you consider only cantilever from fixed end up to R. This is A, this is R. Then length of this cantilever is at 2.4 meter. Now, this 36, now, there is no loading here. Leave it. There is no loading here. But when I remove that one, that 36 there will be transferred here as a point load of 36 kilonewton, and it will create a clockwise couple of 36 into 1.6 equal to 36 into 1.6. This is the best one to do. 36 into 1.6 is 57.6. 57.6 kilonewton meter. Now you have a cantilever where this is the R point, where we got a point or couple. See, the beam will bend like this. Don't see that side. It will bend like this. Now, if I draw tangent here, this is your theta R, this is your deflection at R. Start. Now, see the formula there. Formula you write. This formula. For a point load, now your 2.4 meter will become span. Remember, 2.4 will become span. Theta is formula you write. What is formula? WL square by 2EI. That is 36 into 2.4 square by 2EI. That is for point load. And for couple, formula is ML by EI 57.6 into 2.4 by EI. Tell the answer first. See, for point load, slope ML WL square by 2EI. For couple slope ML by EI. Answer. How much answer? Calculate. 241.92. 241.92 by EI. Deflection R. For point load, WL cube by 3EI. So 36 into 2.4 cube divided by what? 3EI plus 57.6 into 2.4 square by 2EI. Calculate this answer. Calculate this answer. 57.6 into 2.4 square by 2EI. These formula you have to by heart. After some time, if you forget the formula, you know how to derive it. How much answer? Answer. 36 into 2.4 square, 4 cube by 3 plus 57.6 is something. Uh, 331.776. Okay. 331.776 by EI. See there, exactly same answer. Answer once again, tallies or not? First. Answer, perfectly tallying. Tell me, answer, perfectly tallying. One comment from you. Now you are going to the most critical part. If it is tallying means I will go to the next one. Same answer. Okay. Now go to the most important. See, this is where you need good knowledge. Question. So, one homework for you. One homework. Where I will take the cantilever this side. I will apply a point load of W here. And I want slope and this is L. Okay, L problem. From here to here is L by 4. This is the point R. Okay, I'll call this point as C. Okay, I want slope at C and deflection at C. I'll give the answer for you. I'll give answer, you work out that one. Other way cantilever. WL by 4 means, I will do basic calculation. It is WL here. Here it is what? WL by 4. Okay, therefore, I don't require to divide into parts like that. 1 by 4 plus 1 by 4 plus 1 divided by 2 into 3 by 4. Slope equal to 15 by 32 WL square by EI. 15 by 32 WL square by EI. And deflection equal to, moment about that point is 1 by 4 plus 1 by 4 plus 2 times of 1 divided by bracket 1 by 4 plus 1 into 3 by 4 divided by 3 equals so much into 15 by 32. 27 by 128. See, I operated calculator and got the answer. How? If it is wrong, tell me. I will check once again. 27 by 128 WL cube by A is the answer. Work out that one. Okay, now come to the most important question. See the question. There is a cantilever beam of length L. Be very careful. Very, very important question. And I will tell you I will tell you later. I will tell you later. What is IIFTDALTBIIAMB? I will tell you later. Okay. Now, a cantilever beam of length AB has got UDL of W per unit length. Or I will go for numerical. Why? Because we already solved the question last time. UDL of 24 kilonewton per meter. Bookwork WL, I will give homework for you other side. You try. 24 kN per meter for a length of 5 meter. Remember, same question we solved last time and we got theta max and y max. And somewhere at 1.2 meter, we got theta and y. I told you it will come in the next class. Today it came. Yes or no? I told earlier, somewhere inside they want slope and deflection. I told you it will come in the next class. Yes or no? See, can you see it? I wrote somewhere there, not removed it. I told on that day, same question, earlier class we got this answer. Then I told you, next, after some time, we will find slope and deflection at a random point. I will call the point as C now. Not, I will stop at R. R is C. Okay. And I told you, this is the answer. And I told you, you check by Macaulay's method. Did you check and get the answer? This answer. Did you check it and got the answer? Tell me. No, this we got. I told you, same question today only. I told you, next class we are doing it by shortcut trick. I told, when you apply trick, I will tell you how to find slope and deflection at C at 1.2 meter. That time I told you, you solve by Macaulay's method and check the answer. Because Macaulay's, to find slope and deflection here, put x equal to 0. To find slope and deflection at C, put x equal to 1.2. Tell me, did you check it or not? First tell me. Did you check it or not? At least answer. Some, see, if you have checked, see, I told you, it is a very powerful question. No reply. Did you check it or not? By Macaulay's method. I will tell you why I am asking. Did not check. Okay. Can you check today? Can you check it today? Can you check it today? Take a section XX, integrate 2 times, put the boundary conditions and check it. Okay, start. Now today's class, see, right, same question earlier we found maximum. Now today's class, today we require Today we require slope and deflection at a point called, I won't call R now, I will call a point C, new point C, comma, at 1.2 meter from free end. Or they can tell what? 3.8 meter from fixed end. Usually they are center. Center, I'll give homework for you with the W and L. Do it. Okay, start. Now, this I am going to remove now. I am going to remove this one now. Okay, this I want it. Okay, 1 minute. Okay, start. First to go for basic concept. No. First to go for moment area method. Correctly draw the beam. No, it won't take much time. See. This is the UDL of 24 kilonewton per meter. The span of this beam is what? Okay, I can do one thing. I will solve it. Okay. Span of the beam is how much? 5 meter. Okay, now this is A, this is B. See, objective question can come. For the beam shown in figure, what is the maximum slope and y? It is over within no time. Why? Slope maximum, WL by 6CI. Deflection maximum, WL power 4 by 80I. But they can also ask you, what is the slope and deflection? Any random point. Usually they ask midpoint. If they ask midpoint, 2.5. Okay, now they want slope and deflection somewhere here. A point called C, random point C. Okay. First you draw bending moment diagram. This is 5 meter. Now remember now, this is 1.2 meter extra. Red color is what? Red color is extra. This is 3.8 meter. First you draw bending moment diagram. Start. Here BM 0. For bending moment diagram, the point C will not come. Bending moment at A, last time I had drawn it, 24 into 5 into 5 by 2. See, bending moment at A equal to 24 into 5 is the total load into 5 by 2. Tell the bending moment here first. What is the bending moment here? 24 into 5 by 2. You got it last time. Tell the bending moment. This we got last time. 300. Okay, fast. This is 300. And variation is parabola of second degree. Remember, this is parabola of second degree. Okay, now, sign is not required. Hogging, negative. We also want bending moment here. See, this is A, this is C. Now I want, this is 300. Hogging 300. We also want bending moment at C. If I look this way, it is 24 into 1.2 into 1.2 by 2. Tell the answer. 24 into 1.2 into 1.2 by 2. Answer. 24 into 1.2 into 1.2 by 2. 17.28. Don't give wrong answer. 17.28. Enter here. Enter here. 17.28. Okay. Now, BMD over. Now, as per our statement, slope at C is area from C to A. From C to A. C to A. By EI. Area means area of the BM by I diagram. Area means area of BM by I diagram. I should not tell. And deflection at C equal to, this slope at C. Deflection at C equal to moment of the area of BM by EI diagram between what? C and A about C. That is, see, this area. Clear now? That is this area right here. That is this area. This area. This is 300 This is 17.28. Further, see, this is 17.28. It will continue here. No, not that one. This is not there. This is the area. Clear or not? First tell me, clear or not? That area to be considered. Some reason is there for asking. Clear? That is the area to be considered. First tell me, clear or not? Clear. Okay. Now, how to get this area problem? So what I will do is, see, last time it was a trapezium. What I did? It is a straight line. You divide like this, rectangle, triangle. This time, this area, you divide like this. See, you divide like this. Then you get a rectangle of, tell this area ordinate. This ordinate is what? 17.28. And here, high ordinate, how much it is? 300 minus 17.28. Can you tell me? 300 minus 17.28. 282.72. It is 282.72. That will go this way. See? Again, second degree parabola. So this is one of the area. This is other area. The base of this is what? 3.8 meter. The base. This is the point A. This is the point C. This much fully clear? Tell fast. This much fully clear? Tell me. This much fully clear? This much fully clear? Fast. Yes. Okay. Now I forgot right here. I should write this way. 282.72. Okay. Ingriana. 282.72. Okay. Now theta C equal to this, both the area together is 3.8 into 17.28 is one area rectangle, plus for this type of area I told area equal to 1/3 of base into height. 1/3 of base. Base is 3.8 into height is 282.72. This is a base into height rectangle, 1/3 base into height. Answer divided by EI. Fast, tell me the answer. Fast. Tell me the answer fast. One rectangle base into height, other parabola 1/3 base into height. Answer fast. $423.776. 423.776. And deflection at C equal to moment of this area about this point. How much? 3.8 into 17.28 is the area. For that area, distance is 3.8 by 2. 8 by 2 plus another area 1/3 of base 3.8, height 282.72 is next area. 1/3 into, I told you this CG triangle is 1/3, 2/3. If second degree parabola, this is 1/4, this is 3/4. 1000 times told. This is 3/4 of all I told earlier. For this parabola, from here 1/4, from here 3/4. 3/4 of 3.8. Answer complete divided by EI. Tell the deflection in terms of EI. First, tell the deflection in terms of EI. Fast. Tell the deflection in terms of EI. So ಬೇಗ ಹೇಳಬೇಕು. Tell the deflection in terms of EI. ಇಷ್ಟೊತ್ತು ಬೇಕಾ? 3.8 into 7. Don't give wrong answer. Give correct answer. 1145. Don't tell wrong answer. 1145.381 by EI. Over. Now, is the answer perfectly tallying or not? Not tallying means I told you I will not take the class. Is the answer perfectly tallying or not? First, is the answer, last time I told the answer there, it is still there. Last class what I told, answer should come, and by Macaulay's method you will get this answer. Is the answer perfectly tallying or wrong? Tell me. What answer we got and what answer is there? Are they tallying or not? In my class, when I find slope or deflection by different method, if or analysis of indeterminate structure or any question, if answer is not tallying, either there should be a mistake. Mistake can be deliberate or calculation mistake. If it is a technical mistake which I cannot understand, that is the last day of my teaching I told you. So answer is not tallying, because last class you write, he only told theta c should come 493.088 by EI, deflection should come 1277.0736 should come. This is what he told last time. You write there. But answer is not tallying. So write. Therefore, now two options. Either I correct this one, or what, tell me? Either I should apply a correction. If there's any mistake is there, I should find out the mistake and correct it. One option. Tell me. Second option, which you may not like, which is nothing can be done. One option. Either I find the mistake and then correct it. Tell me second option. If I cannot find the mistake and answer is not tallying, second option, first. In case I find a mistake, okay, I can check it. But if I cannot find the mistake, then tell frankly, no problem. If there is no mistake, then first, don't waste time. If I cannot find the mistake and answer not tallying, only one option left out. What is the option? Only one option left out. Tell me frankly, no problem. What is there? I am not under tension. I am not tensed. I am enjoying like anything. See, tell me. First, I want comment. If in case mistake is not corrected, the only option left to me. Tell frankly what is there. Don't bother. See, you are not giving answer. You know what I want to tell. Some do not want write. You write, no problem. Below is not rectangular. Yaurri nimdu yaru Nandakumar. When I divide this way, 17.28 rectangle alva adu. Yauralidira. I am asking you, you leave it, no problem. That you leave to me. Below is not rectangle, leave to me. Now, in case I cannot find the mistake, tell me only option for me. You tell that option. Don't correct it now. If I cannot find the mistake, only option. You tell frankly what is there. Let the people know it. You have to leave the class, Allah. I should stop the teaching. Yes, I still stick to that, what? My promise or my conclusion. I still stick to it. Not able to solve means no more class from me. Okay, now I will do one thing. I will put on hold. Hey, you wait for some time. I will come later. Let me first check whether first of all this answer is correct or not. That answer is given last time by what? Last time given by Macaulay's method. Okay, now time being, leave it now. I will come here. I will tell you, hey, you wait for some time. You wait for some time. I will go to second option. Second option. That is the trick or special. What you do? Consider the cantilever A up to only P. C. Only C. Now remember, consider from A up to only C. Where is it here? Only up to here. That is, your cantilever is of length 3.8 meter. Okay, there. First apply whatever load is there. There is a UDL here. How much? UDL of 24 kilonewton per meter. Some will tell, sir, this is the best method. Okay, now, see, I told you, cut out this portion. Then 24 into 1.2 will give a point load. Nodi, it will touch the beam. Okay, 3.8 meter. 3.8 meter. Span is 3.8 meter. That is red span. 3.8 meter. Now, this is a point C. Red color C. This portion you throw it out. Then a new load will come equal to 24 into 1.2. Tell that load first. A load of 24 into 1.2 will come. How much? A load of 24 into 1.2. You don't leave the class. Don't bother. I am there. 28.8 kilonewton. 28.8 kilonewton. And a couple will come. How much couple will come? 24 into 1.2 is the total load from removed portion into center is here into 1.2 by 2. Tell what is that couple. Now you got a UDL, one point load and one couple. Tell what is the couple. From the removed portion, apply a couple. See, some will tell, sir, instead of all these things, this is the best solution. Tell yes or no. This is the best solution. Tell me yes or no. Cutting the remaining portion and introducing load and couple is the best one. Tell me yes or no. This is the best solution. Tell me yes or no first. Instead of all the struggling, cut out the remaining and go for it. Okay, now start. I will do one thing now. Okay, here, see. Start now. Now, slope at C equal to, apply one by one. Do one thing. Come in order. First couple, ML by EI. Couple is 17.28 into 3.8 is the ML by EI is slope. Plus, due to point load, WL square by 2EI. 28.8 into 3.8 square divided by 2EI is for point load. You write here. This is for point load. And for UDL plus 24 into for UDL slope WL cube 3.8 cube by 6EI. Now tell me what is the slope due to couple ML by 2EI due to point load WL square by 2EI due to UDL WL cube by 6EI. Now calculate the slope. Now calculate the slope. First, I am not under tension. I am not at all under the tension. Calculate the slope. First, I told you last time, next class is very, very important, especially for concept. Learn this concept, it will improve 493.088. 493.088 by EI. And next, deflection at center. Start. Due to couple, ML square by 2EI. How much it is? 17.28 into 3. Exam, they will ask only one of this one. Suppose it's an objective question, maybe for GATE or engineering service. Usually for PWD, they will not ask. But they can ask into 3.8 square by 2EI is for couple plus for point load 28.8 into 3.8 cube by 3 EI for that point load plus for UDL 24 into 3.8 power 4 by 8 EI. See, ML square by 2 EI, WL cube by 3 EI, WL power 4 by 8 EI. Calculate this way by shortcut. This is the answer I told you by Macaulay's method. Tell now, deflection fast. Answer 493.088. 493.088 by EI meter down. This is that much radian clockwise. Oh, aha, Kannada. Aha, tell me. Perfectly tallying or not? What answer I told you last time should come? Is that answer perfectly tallying or not? Tell me. Is that answer perfectly tallying or not? What I told last time, answer, is it perfectly tallying or not? See, I told you, not at all bothered about what? 493. Ayyo. What 493? Oh, new hale answer adu. Hale answer. 1 2 okay 77.074. Not 736. Not 74. Not 736 only. See, not 736 only. Not even 4. Tell me. Perfectly tallying or not? Tell me now. Answer, if you had full number, it is not 736. Perfectly tallying or not? First, I want comment now. What answer I committed before the class? This is the answer has to come. In my class, before the problem is solved, if I tell, sometime I tell, this is the answer has to come. No beam in the world can give different answer. No beam in the world can give different answer. You first comment, tallying or not tallying? One last comment from you, that's all I want. No, I am asking, now when I do my shortcut method or trick, that is removing the remaining cantilever and introducing node and couple and going for simple formula, cantilever reduced length and apply formula. I want first comment. Tallying or not tallying? Answer. Both tallying. Okay. That means there is some mistake. Where? Tell me. By moment area method or trick, there is some mistake we committed, or rather I committed. It may be deliberate or it can be mistake because I am not knowing the concept. If it is a mistake because I am not knowing the concept, that is the end of me in teaching field. So it should be deliberate. Anybody will tell, ಕನ್ನಡದಲ್ಲಿ ಸರ್ ನೀವು ಬೇಕು ಅಂತ ಮಾಡಿರೋದು ಹೌದು ಕನ್ನಡದಲ್ಲಿ ಸರ್ आपने जानबूझकर किया है यस जानबूझकर ही किया है पता लगा था मुझे I know that's wrong therefore tell me something seriously wrong when you applied moment area method. Tell yes or no. No, something seriously wrong when you applied moment area method. You just tell yes or no, sufficient for me. I don't want further comment. Just tell me yes or no. Something seriously wrong. Yes, I will tell the answer now. See, that mistake I deliberately did because I have seen plenty of YouTube classes. I have gone through, go through YouTube class. You type deflection of cantilever beam. See, people will do one thing. They will do this way and tell the answer. It is wrong. So many people make this mistake. At least from today onwards, if they see my class, they should learn that they made a terrible mistake. They made a mistake. So, shall I tell you what is IIFTDALTBIAMB? Shall I tell what is this mistake? I already wrote the mistake in short form, code name. Shall I tell what is the meaning of IIFTDALTBIIAMB? Shall I tell it? Shall I tell it? Yes. Now, see, I will not give the answer today. I will tell you what is the mistake. 1 day time for you. You think for 1 day and tomorrow suggest me, if possible, that mistake, how to correct. Agreed? See, I can correct it now. No. I want to teach everybody, all the people who make the mistake, at least they should realize. Okay, therefore, now I will tell what is the meaning of this one. So tomorrow's class, I will tell you, I will remove that mistake from here, then you get the answer. Okay, done? Tomorrow I will remove the mistake. It is my guarantee. Tomorrow answer, this will not come. This 423.776, tomorrow will change over to 493.088. And this 1145.381 wrong answer, tomorrow will change over to 1277.0736. Otherwise, I will not take any more classes. Agreed? Okay. See, make a note. See, I write here, this I am removing. See, it is foolish. It is foolish to divide the area like this. It is foolish to divide the area like this. See? Like this. Because, see, now, because it is very sorry, very sorry for using harsh words. People who make the mistake, you should know that I am not insulting anybody, but mistake you made, correct it. It is a mathematical blunder. It is a mathematical blunder. Very sorry to use the word. See, it is foolish to divide area like this, because it is dividing that way is a mathematical blunder. Then someone will ask, what is the blunder? Wait for 24 hours. 24 hours. I will tell it here. With the proof I will tell. With the proof I will tell why it is a blunder. Agreed? See, that mistake deliberately made by me. Do you think in my class answer not tallying? Is it possible? Those who know me already, is it possible that I don't get the correct answer? Or I make a mistake in the principle? Okay. Calculation mistake, okay, agreed. Print mistake, okay. But principle or technical mistake, I told, it is not arrogance. It is called confidence. I can never make technical mistake. No. Neither earlier, nor now, nor in future. निन्ने तनक ಇಲ್ಲ ಇವತ್ತು ಇಲ್ಲ कल भी नहीं, आज भी नहीं, परसों भी नहीं. Nowhere mistake will be made. So tomorrow wait, I will explain what is the meaning. Now meanwhile, you think and try to find the mistake, and also, if possible, find remedy for it. Anyway, remember, actually it is better to go for a trick. Tell yes or no. The trick will give fast answer. Tell yes or no. Trick will give very fast answer. See, trick will give very fast answer. Tell me yes or no. If you remove that cantilever remaining portion, apply here, within no time you get the answer. Yes. So objective paper examination, the trick is better. In a cantilever, if they ask slope and deflection somewhere in between, the best is not moment area. See, moment area means you draw the diagram, etc. Trick. remove from there up to free end, introduce load and couple, and happily substitute and get the answer. Okay. Tomorrow I will rectify it, or I will tell tomorrow what is the mistake with the proof I will tell. Okay, thank you. Hope at least there is something for learning by this class. There is something for learning by this class, yes or no? At least something to learn. Ilva? Okay, thank you.